Like back is like, yeah. How's it going? Enjoying life? Yeah. Who's saying yeah? Yeah. My man, huh? Yeah. I hope you're all prepared for your midterm. If you're not, we're here for you. And unfortunately, there's no strike, so you have to study. Now, this review seminar is done by me, which is Adib and Elankrit, who's not here today. So you can just consider me as your modulator. And today we're going to be talking about how you can prepare for your AO8 midterm, as well as going through some past year exams. I'm pretty sure Purva has sent you some past exams, right? So definitely go through those, as past year exams mostly get repeated, like the same type of questions are going to be in your same exam. So the best resource to prepare is just what has happened before will just continue to happen. Now, we're going to be covering some basics of Python just to review some of the materials, and then we're going to be moving on towards solving some of the questions and leaving you with some challenging questions in case you're interested to pursue even after the seminar. Now, let's go through some examples, and I want you guys to shout. So what's the difference between this and that? Who can say that? Yeah, go ahead. Exactly. So the first one is normal division, which will return floats to you. That is, doesn't matter what your division will be, it's always going to be returning a float. But the second one is an integer division. What does this do? Exactly. So it will give you the remainder of a division. What's the order of precedence? What's the highest one? Exactly. So the power rule or exponentiation, the double star is the most highest one, and the rest, I think you guys all know it. And these are the answers, which I rushed. Haha. But let's do some examples. 6/4. Anyone? Wow, that's correct. And how is 6/4 again and again? Let's go through it. Nice. 1.5, 1, 2.0. You know this one definitely. And you probably can do that in the calculator. Now you might say, well, that's way too easy. Is it going to be our midterm? Well, this in fact was a multiple choice in one of the past exams, and not everyone got it right because people make dumb mistakes during the exam. So a good suggestion is review your answers when you're solving it. Maybe you're just going to misread or miswrite, and it's really important for you to make sure you're reviewing whatever you're writing down on that paper. Now, the built-in functions are some of the functions that you're going to have seen in the classroom. Some of them you need to memorize, like how you use the sum or other types of functions. But almost everything will be provided for you in the exam. So you don't need to worry about the list modules or all the different things you can do in Python. So you know round. What is the answer, guys? Can we have a union answer? Like, what is the first digit? 5, nice. So as you can see, round gives you back a float. And that's always the case. Unless you're rounding to 0, I'm not sure, but usually it's a float. And now if you're putting a negative number, instead of moving the dot to the left, you're moving it to the right. So as you can see, you'll be like, the direction will not, you won't truncate from left, you'll truncate from right, and as a result, you go to 1,000. Now, the same thing, if you're just doing normal round, it will consider it a round to the most nearest integer, which is, again, a round with passing the second argument as 0. And if you're finding the minimum, probably you guys know how you find the minimum, right? You know absolute value, and you know the power. Now, these are some of the things we just go through until you warm up. I hope you're all 100% familiar on this material, and as we get going, the review will get more challenging. Does anyone have any questions until here? Awesome. So let's move forward. One of the important things you'll do in your exam is writing new functions. So make sure you're following the function design recipe, from defining a meaningful name to defining what is the type of all of your parameters, what is the type of your return, putting a doc string. Sometimes you also need to put doc tests. And then it doesn't matter what function you're trying to write, be careful with writing it as efficient as possible. At the end, make sure you're not having any typos, syntax errors, or any type of misspelling in your code. For example, you're not missing out underscores or whatever you're doing in defining stuff. Now, when you're calling a function, probably you know how you do a doc test. You're going to be writing this symbol 3 times, then the name of the function, then your input, and the desired output. An important thing to consider is your desired output will have a type, right? So imagine you're inputting something to your function, and the output is a string. Make sure whatever desired output you're writing has quotation marks, because that is a string. And that's something you might be tripped up. So what is the description of the function? This is what exactly your function is doing. As you know, we usually start with the keyword return. We do not say returns. That's 1 mark lost. And return is used when your function actually returns something. Here it's returning an integer, so we are using return. But sometimes your function returns none, which means it's not returning anything. When you write return, definitely try to always mention the name of your parameters in that explanation. So as you can see, foobar has been mentioned here. Make sure all your parameter names are also present in that single line or a couple lines defining what your function does. And also make sure when you're saying return, what type is your return. So return foobar added to bool as an integer, something like that. Yeah, go ahead.
Are you going to post these slides?
Yes, definitely. So you don't need to be writing all of this. Everyone's like, oh, yes, I'm free. I'll be sending all the slides. Some of the questions here will also have answers. So in case we go further on, you don't need to write anything down. Just pay close attention and ask questions. I think that's the most important thing we are trying to do today. Now, after you're done with writing a lot of the fancy stuff about your function description and etc., it's the function body, which is the actual code of your function. And usually the functions you'll be writing down will have a return statement. So sometimes it's a good idea to start with whatever you want to return, like in the end. Let's say you are going to be returning an int, write return, and keep a placeholder. And this will give you some idea that, OK, I know the top of my function and the bottom. So filling in the middle is like filling the sandwich. It's easy. And make sure that you're indenting. That's when you're writing your code, it will always give you an error if you're not indenting. But during the exam, the paper is a paper. So make sure you're indenting as needed. Again, here you're seeing an example. You're defining a meaningful name. You're defining what is our parameters, what is the type, what is the return type. And then we're explicitly saying that we are returning the type that we are returning. We are mentioning all the parameters specifically with their names. And we are also putting some doc tests here. There's no need for indenting the doc test. This might be a single typo made there. The doc tests are all on the same indentation level. And as you can see, the function is in the most simplest form, right? You're not saying if num module 2, whatever. No, you're just putting in a single line to define everything. Go ahead.
How do you show indenting?
You don't need to be really that picky on it. As long as you're following the same type of, you don't need to be putting, you don't need to bring a ruler and say, is it 1 centimeter or not? Just as long as you're a bit further back from each line you're beginning based on the indentation level, that's fine. Sometimes you're going to have a couple if-else statements like as a nested function stuff, so make sure that you're properly indenting. And these are the stuff that will give you 50% of the exam. So if you're wondering what is 50% of my mark, it's just making sure you're writing things properly, you're having a general idea what you're doing, and what you're writing down is similar to what you've been seeing in the class over and over. Now we're going to start moving on to reviewing some of the specific materials we've discussed before. One of them is conditionals. As you know, if-else statements are going to be used as if, then the statement. Make sure the statement you're putting will return true or false, right? So if you're saying if something, that thing should return true or false. Sometimes you're going to see ways in which you put, for example, if num or whatever. And these are used in Python because a number that has value is also considered as true when you're passing it to if statement. But in general, for your writing a neat answer, I suggest being clear on what you're writing, right? Now, after you write your if statement, make sure you do not confuse elif and else statements. Any if statement will be checked. Elif statements will only be checked if the prior if statement has failed, and else will run no matter what, if anything before it has failed. This distinction is going to be really important in some of the questions that you need to say if elif or just 2 separate if statements. Am I going too fast or the speed is good? Nice.
Could you repeat if
Oh, of course. So as you know, if you say elif, elif means the first if has failed, and so I'm checking the second one. But if you say double if, it means I'm going to check both no matter what. So when you need to check two conditions separately, and you need to make sure, like, if any of them is running, I'm doing the things I need to do, use if. But if you're checking a single condition in like the different possibilities it has, use if, elif, else, based on how long it will go.
So else will check like, if the previous is false.
Exactly. So if all the ifs and elifs have failed, else will run. And I say think of it as English, right? Like if you're reading your code, if this happens, else if, or elif that happens, or else I'm going to do that. And that should make sense to you as it makes sense to Python. Else statements will run if has failed, right? If has failed. Wow. And make sure that you're indenting else as well. Sometimes people do not indent else and like put it inside the if. You know, that's wrong. Else should come out and have its own type of block. And as we mentioned, else if or elif statements will only run if the if has failed. So here you can see if foobar is greater than 18, the code will run. Otherwise, it will check again. That's what we call an elif statement. Now, a neat thing you can do with using if and elif, I'm just going to write this in the board. Oh, there's chalk. I have so many wires. Wow, it's crazy. Right, so sometimes you need to check if your number is inside some interval. Let's say you have an interval of numbers going from 10, like 20, and so on. And so you want to check what part of the interval is my number. Is it less than 10? Is it between 10 and 20? Or is it more than 20? And a neat way to do that with if-else statements is saying if your num is, for example, less than 10, do something. And now if this fails, it means your number is over there. Like it's anything from 10 afterwards. So you can say elif my num is less than 20. Now basically what it does, it says, OK, if it has failed, which means we are further down the line. But elif might say, no, the num is less than 20, which means we are not after that line. So you easily find the interval from 10 to 20. In other words, this is the same as saying if your number, just going to write, if your number is less than or equal to, bigger than or equal to 10, what is this 20? Does it make sense? So instead of repeating the whole thing and trying to put boundaries around your number, you can use if and elifs to just check step by step if you're inside that interval. And now you easily know if I'm using else, it means my number is all the way over there. This is not less than 10, it's not less than 20, it's more than 20. In general, you can use it in both ways, right? Like both of them are correct. Whether you want to say is age is less than that number and bigger than that number in the elif statement, or directly put it across a less than and a greater than sign. Just make sure you can write in both ways, because you don't know, maybe sometimes you're going to be asked to read a code rather than write a code. Does it make sense? Yes?
So I have a question for this one.
Yeah.
So is it like less than or equal, or is just less than 20?
It could be used in both ways.
Could be used in both.
Yeah, it just depends on what exactly you're trying to achieve. But you should get the idea that I'm moving step by step by using an if, elif, else block. And you can repeat the elif, right? You can say elif num is less than 30, less than 40, less than 50, and just go one step ahead at a time. Go ahead.
Instead of using else, can we use else again at the end, like as our conclusion of the portion?
If you want to use elif again, you need to say elif, I'm going to write it here. Elif num is greater than 20, right? Yeah. In general, they're both correct. If you go to Python documentation, it will say, please use an else statement to make it look nicer. But most of the times what programmers do is they put an elif num is greater than 20, and then they put an else saying that, oh, damn, something is wrong, right? Because if you're covering all the ranges and you still go to else, it means something is messed up in your code. That's why I suggest using else. That's easier to do. Now, again, something we really, really want to emphasize on. If you're saying if and elif, it's different from saying if and if. If elif will be checked once, and only if is failing, it will go to elif. But double if will be checked twice, no matter what. And so you can use it for different scenarios. Like in the first scenario, you're just trying to find where age is located. Is it to the bigger than 18, less than 18, and we're trying to find the interval. But in the second one, we're just checking for age over and over. Now, if age is equal to 18, can you tell me which blocks will run and which blocks will not run? Like starting from the first one. Go ahead.
If it's equal to 18, the second one is going to be run.
What do you mean the second one?
If age is less than or equal to 18, do the other thing.
Let me bring my pointer. So, I have a pen here. Nice. So let's call this 1. Let's call this 2. Let's call this 3. I think it's better than my handwriting. Anyways, so which ones will run if age is equal to 18?
4.
4 will run, but there are also some other stuff that will run. All the way in the back.
1 and 3?
1 will run 2, 3 and will all run 2, and that's correct. Now let's go through it together. In the first one, we are saying if age is bigger than or equal to 18. Well, if it's equal to 18, it will satisfy being bigger than or equal to 18. So this will run. And elif won't be even checked. So we don't even care what is written here. That's why if elif is really tricky to deal with, because if the first one passes, the second one will even be checked. We don't even care what is written there. In the second scenario, we'll check here separately. We'll say, is age greater than or equal to 18? Well, yeah, of course. We'll run. And then we'll check again. Is age greater or less than or equal to 18? Yeah, it is. So we'll just run again. In other words, double if will be checked double. If elif could be checked twice, or it could be checked once, depending on the outcome of the first if state. Go ahead.
But like in the matter of returning the code, the fourth one is going to be, the code is going to be returned.
You mean if all these 4 were in the same Python script?
Yeah.
If all of them were in the same script, we're going to check from the top, right? So we'll check if age is bigger than or equal to 18, and if here is a return statement, we'll exit from number 1. Because once your function is done, your function is lazy. The moment it finds a return statement, it's done. I don't even care what you've been cooking for me. I want to get out, right? So even if the remainder of your program has the possibility to run or even do stuff, once you hit a return statement, you're done with that function. So if these, the indentations were about returning things, number 1 would run, and you'll return, and you're done. The rest won't even be checked. Does this example make sense? This is really fundamental in understanding if, elif, and else blocks. Now, a lot of time you're going to be using inequalities if you're checking numbers. Later down the road, you're going to be using list operations, like you might say if this specific number is inside, oh my God, if this num is in list, that's again a possibility, right? In general, there are many ways you can check an if-else statement, but the most important ones are comparing numbers or using in state. Is it in that or is it not in that, etc. What I recommend is just think of it as English, right? Like you want to say, is my number inside the list of numbers? If so, do that. Else, do something else, right? That's simple. Now, a common first midterm question is to make a function that classifies stuff. And we're going to be seeing an example of that too later on. And the reason for that is this idea is fundamental. Doesn't matter where you're coding. Are you like coding machine learning algorithms, or you're just coding some Hello Python, whatever your program, you're always going to be using these type of if-else blocks. And so think about your code. Think what my code is exactly trying to do, and bring that English idea into code, which is really important. Now, let's try to do an example. Let's try a function that will return whether a given user is qualified for free subway rides. And we know the way the program works is if you're 10 years old or less, so less than or equal to 10 years old, you will get free ride. If you're between age 15 and 18, you'll again get free ride. And if you're over 45, you'll also get free tickets. So the way we're going to be writing this down is here. How do we go for it? Let's start from the beginning. I will define a name that's really easy to use, right? Is free transient. Makes sense. I will define the input, which is the age. It's an integer, and my function is returning a boolean. This s should not be there. 1 minus point for the person who made this slide. You should say return true. Mention the name of your parameter. And also mention everything that could happen. You're going to be returning true or false depending on what's happening. There are some dog tests as usual, like true or false. Use this based on the logic of your code. And you don't need to indent. Here has been indented. You cannot indent. In general, it's better if you're not indenting a dog test, but both are correct. It depends on your Python version. Anyways, so how do we do it? In the previous slide, we talked about 3 different possibilities. Comparing with 10, comparing between 15 and 18, and comparing after 45. And as you can see, you can use an if statement for the first one. If age is less than or equal to 10, return true. Otherwise, or else if my age is between these 2 specific numbers, return true. If age is greater than or equal to 45, return true. So these are all the 3 conditions that will give you free tickets. And else, return false. Now, a neat thing to do is you can actually remove this else statement and bring return false there. And I hope it makes sense to you, right? Because your function will ultimately run the else block and it will return false. So you might just say return false. If none of the cases are true, then just return false.
So if you write the else or if you don't write it, that's the same.
Yes, exactly. So, and this is a good check, right? You're going to make sure that everything is working properly, because an else return something is the same as just returning it in a function. Go ahead.
Would it be wrong if we did put else and then return false?
I do not think they're going to reduce marks. Even though it's recommended that you write in the simplest form, these type of like small mistakes are usually ignored. But the beauty is in understanding why it doesn't matter to write else or not, right? Because else will always run in the end if none of the conditions are true. And so you'll be ultimately returning false. And now we're going to start talking about some of the more advanced ideas. This is in your midterm. So make sure to pay attention. Do you have a question? Anyone? Great. So what is a short circuit? It's just a really fancy name for what we've been talking about here. And that is, if you want to compare separate ideas, for example, you have a logical operation like and, or you're trying to compare different things, a short circuit is a mechanism where the moment you've reached your conclusion, you'll be stop checking. Always think of your programs as lazy. No, your function is lazy. Imagine you have an if statement, and you're saying if something or something else, right? So you're using an or statement and you're checking. And your if will run as long as one of these or both of them are true. Now, if the first one is actually true, well, you know that or will evaluate to true, right? In other words, the moment your if, say, a statement reaches a single true and says true or doesn't matter what I'm checking, I've already had my true. So the laziness kicks in, and you don't even check the second one. You'll go for execution. In other words, this is what we call a short circuit, right? You don't need to check the second part of the or statement if the first one is true. Because you already know that the or will be true, right? True or false is true. True or true is true. So if the first one is true, I'm done. And this could be a technique you can use, right? Like if you know that the first one being true, I can just directly go ahead. You can put the one you're talking about in the beginning of or state. So it's really important. The positions around the or matters. Even though the last evaluation in mathematics is the same, in Python it could not be the same. Because, for example, if the first one is equivalent to true and you'll be running, if the second one could be buggy, right? Imagine there's a condition in which the second one will give you a bug, but the first one is true. This code will still run. And so you have to be careful about this kind of stuff. When you're using an AND operator, you have to check both sides. So here there's an example. If x is bigger than 0 or the second condition is happening, the only time we'll print condition met is when both of these are true. So if the first one is false, then your laziness kicks in again. You're saying, well, false and true is false. False and false is false. So if the first one is false, I don't care. I'm done. I'm going to move on to the other statements, maybe the next elif or the next else statement. And this is a key idea both for understanding your programs as well as using it for your own benefit during coding. So just to summarize, OR will evaluate to true if the first one is true. So you don't care about the second one. So the moment you see one part of OR is true, you're going to be moving on and executing the block. With AND, the opposite is true. The AND needs both sides to be true. So if the first one is false, you're going to be saying, well, there's no point checking the second one because I'm not going to run anyways. So I'm just going to move it on to the next block or any block after that. And that's a powerful way to not only simplify the logic of your code and sometimes avoid situations in which the first one is true and the second one is buggy, but you're going to run eventually since the first one has been true. Does it make sense? Great. That's in your midterm. Yeah, like a small hint. Anyways, we're going to be moving on to strings. That's enough if and else statements. As you know, a string is a class in Python. We're going to be learning about classes later on. And you can think of it as a collection of letters or characters. These characters could be anything from just a space to large sentences. And as you can index them. The 0 index refers to the first character. -1 refers to the last character. And I'm pretty sure you're all familiar with how you count the indices. But in case you need a refresher, let's say I have a string called hello. And I can consider that as being a sequence of characters. Now, the first index is 0. And it will just keep counting until the last one. And if you want to go from right to left, the opposite way, you're going to start from negative numbers. So this is -1, -2, -3, -4, and -5. Now, the length of a string will return you the total number of stuff there. So what is the length here? 6. Exactly. So the length is 6. And this is an interesting thing that you'll notice, that if you're going from right to left, negative len will be the first element, right? So if I say my string, then index it at the negative len of string point, negative length of the string is the index of the last element. Sorry, the first element. So negative len is going to be -6. What is a -6? You go from right to left and you reach h. So this will be equal to h. And if you want to go from the opposite way, you're going to see that this is equal to the length of string -1. So if you want to find the last element, you can either say what is in the last part. I'm just going to bring this down. Yeah, poor monitor. Anyway, so you're going to either say a string -1, which will give you the last one, or you can say a string. Can you guys help me out here? What should I write? Using positive indices. Len, okay, go ahead. Len of what? Yes, and is it enough? Exactly. So len of the string -1 is the index of the last element. Just be careful about with your indices. Now, why did they do that? Why does it start from 0 and then -1? I don't know. It's just convenient. The way you want to look at it is if you're summing the indices, you know, if you sum 0 to -6, 1 to -5, and etc., you're going to get like an interesting sequence of numbers, but that's all my mind can get.
What did you write there? What did you write up there?
This one?
Yeah.
So this is saying string, and you're indexing at the len str -1 position.
So,
Go ahead.
isn't like len of string is 6 and 6 minus 1?
Exactly.
Okay, yeah, so you're referring to the last string.
Exactly. Or you can just say -1. That's easy. Anyways, let's move on. So here are a bunch of examples. The first one is going to be a single string. Foobar 0 is going to give you the first character, and so on. Indexing from negative, as we went through it, we'll start from the right. So foobar -1 is m, and foobar -8 is n, and foobar negative length of foobar is foobar negative length of foobar Exactly. And now as we move on, you're going to be learning about not just getting a single index, but also a slice, a portion. And slicing is very important because you're going to be seeing it over and over in the course and as well as in your individual examples. So how do we slice? Just going to. I should bring some light here. Oh, which one is it? Nope. Oh, that's good. Alrighty. Can you guys see this good now? Amazing. So just to review indexing. As you know, when you're having a string, let's say this is my string, and I'm going to be writing the exact string down. So let's say I have a string. I'm just going to call it hello for now, the stuff we've been talking about. Now, if you're saying my string, and you want to get one part of it, let's say I want to get it reversed. Usually what you do is you have a start position, you have an end position, and you have a step count. So you're saying from what part until what part I want, and what is the step size? Am I just going 1 by 1 or 2, 2 or 3, 3? Like what is your jump size? Now a simple example, let's start with saying I just want the hell part, for some random reason. Now if you want to have hell, you want to say this is 0, this is 1, 2, and 3. So you want to start from the index 0. You want to go all the way to 3 or 4? 4. Nice. And you want to use a step size of 1. Why 4? Because we always not include the last one. So we'll include the one before that. And this is really long to write. So by default, if you just say until 4, it would have the same meaning. By default, you start from the 0 part, and you have one step size. That's the default ideas. So if you don't see them there, they're there, but just hidden. Now, indexing in positive way is easy, but indexing in negative gets a bit challenging. If you want to index in negative way, you should mention -1 because you're going from right to left. So you're taking negative steps. And now there are two scenarios that happen. Usually you're going to have negative numbers here as well, right? So you want to say, I want to start from -1. I want to go all the way to -5, and my step size negative. So you're going to be starting from here, -1, -2, -3, -4, and you're just going to end up returning whatever you've had. So you're going to say -1, -2, -3, -4. I'm not going to get to the last one, so this weird thing will be your output. Be careful. If you're not providing -1 here, and you're just providing, like, let's say 1 here, your function will actually count from -1 to -5. And when we're wondering, well, how is that possible? Because we need to go from right to left. So it will just say, I'll return you an empty string. You can slice your string, doesn't matter how you want it. But if you're doing something that's not valid or it has problems in it, it will just give you an empty string. Because it's saying, I'm going to start from -1 and magically go to -5 by moving forward. I can't do that, so I'm just going to return you an empty string. And so I highly suggest playing with this, right? Like play around. Like, I don't know, if you're starting from a positive index and you're going until a negative index and you're having 1, what will happen? And these kind of stuff are good to practice so you get an idea what's happening. But the key here is that usually we don't get an error. We get an empty string back. So if your slicing is wrong, you're just going to get an empty string. And in general, negative indexing is not something you're going to be using that frequently in the course. The main use case of it that I do remember from some of the exams is saying string, then -1. And what this basically is doing is saying, I don't know from where you're starting or to where you're going, but do it in the opposite way. So since you're saying -1, it will say, OK, I want to start from right to left. I'm starting from the first thing that exists. So this is equivalent to saying I'm starting from -1. I'm going until whatever is possible. So I'm going until the negative length of my string. And I'm taking -1 steps. So what is the output of such function? Exact. So you're going to be reversing. So it's really important, right? If you're using -1, your function will by default start going from right to left. So the starting point will be -1. The ending point will be -len, and everything will be reversed. And there's a handy thing that the negative index is equal to the positive index minus the length of string, which you can just do some tricks here, and you'll see that it actually makes sense. Now, again, here's an example of different slicing. Again, we've gone through this stuff, so you probably can understand all the examples here. And make sure that you are, if you're using negative indices, you're careful with where you're starting from, where you're going. And I do suggest you to verify these examples on your own after the class, especially the last one, right? If you're starting from 8 and going to 1, and then you're taking -1 steps, how is that possible? And you'll see that it will give you the exact same thing written here. Now, again, be careful. If you are not doing something that makes sense, you'll get an empty string. You will not get an error, and you will get an empty string. So based on how you're using your program, the results will be different. And so, for example, if you're going from 5 to 2 with positive index, it's not possible, right? So you're going to get an empty string back. And an empty string by default will be false if you're using it in an if state. So if you say if empty string, it's like saying if false. So that's the same idea. And there are some string methods. You're going to be getting a sheet defining all these different methods, from .lower to .upper to len, all those kind of stuff. You don't need to memorize them, but make sure that you know the edge cases. In the sheet provided in the exam, you're going to be getting an idea of what these functions do. But if the description doesn't make sense to you, you can't do anything in the exam. So just make sure you already know a bit about what these are doing, and you're leaving the specific syntax for the exam. .lower will use lowercase letters, and as a result, you will have every single case in lowercase, but the numbers will stay the same. And these are all the other ones. Something that trips people is alnum. This is alphanumeric. Alphanumeric is true either you're an alphabetic letter, like A, B, C, D, or you're a number, like 0, 1, 2. So alnum is going to return true if all of the characters in your string belong to these two categories. So if you're seeing an @ sign, that's going to give you false. .isDigit will just check for the number. .isAlpha will just check for the alphabetic part. So these three are kind of checking whatever is your string. And usually you'll use them for characters. You don't usually use them for a large piece of string to see if is it all numeric or not. But you could be used for any possible scenario. Now we're done with strings, and we know already about conditional. So let's get to the spicy for loop stuff. For loops will be used for looping over a string, a list, a range of numbers. It could be anything. For example, here for character in foobar, we are going through each single character, and we are adding them to a collecting string variable. And each time we are adding it, we are adding an @ sign afterwards. So for any iteration in the loop, we'll just keep adding one @ sign, and you will see this weird string in the end. A really important thing in for loops is for loops. I'm just going to write it here. I think it's easier. When you have a for loop, you're saying for, let's say, for num in this list, right? When you're going through each step of the for loop, the number of times for loop will run is equal to the number of items you have here. It could be number of items in the list, the number of items in your string, doesn't matter what it is. And now sometimes imagine you're trying to build a fence, right? Like for building a fence, you're saying you want to have a for loop and you want to build one of these, fences. Now you might say in my for loop, I'm going to say for I in range 3, add a fence, and then add a, let's call this X and let's call this Y. You might say, well, if you want to have a fence, what you want to say is for I in 0, 1, 2, my fence will be added with an X, and then I'm going to also add a Y to it. Something like that. Now, what is the problem with this code? Of course, that's a problem. Fence is starting from an empty string. Okay, if our end goal is to get something like x, y, x, y, x, what is the problem? It's a dirty code, right? What is the output? Go ahead. Exactly. There are two things that make this a bit complicated. One of them is I'm saying for I in this list, but I'm not even using the list or I. And the reason for that is range works the same way. When you say for I in range 3, you can think of it as a list from 0, 1 to 2. So that's why my for loop here is behaving exactly like saying for I in range 3. Now I'm not using my I because I don't need it. The second thing to notice is for any time I'm adding an x, I'm also adding a y. So in the end, I will have an extra y in the end of my string, which I don't want. And that's a fence problem in for loops, in which you can't use the same for loop to add both x and y's, because the number of x's you have is different from the number of y's you have. So you either have to remove one extra y in the end, or you have to let go of adding an xy in the end and just manually add the last one. Does it make sense? This is going to be tripping you in the exam because you're going to forget that a for loop will run for the same number of times that's defined in the first line. It won't care what's your desire. It will just run as long as it needs to. And so make sure if you're having a fence type of problem, you're taking care of the last character or the last part manually, either by adding something or by doing one less iteration and doing the rest manually. And that's for loops. Now let's move on to while loops. The main difference is while for loops will run for a set amount of iterations, while loops will run as long as the condition is true. Here you're saying my counter is equal to 0, and while the counter is less than 5. And so as long as your counter has not reached 5, this will keep running. And in the end, your counter will reach 5. And so the while loop will just stop. In order for your counter to go from 0 to 5, you need to go through the while loop 5 times. And that's why 5 is the number of times the while loop runs. Does it make sense? Great. Now again, you're going to see the type of fence problem here too, right? If you want your counter to not to do something 5 times, but the number of fences is one more or one less, the while loop will have the same type of problems as for loops. So be careful to take care of that last experiment yourself. And before moving on to lists, we're probably going to take a break, but you already know how you can differentiate between for loops and while loops, right? If you know how many times you're going to be running, use a for loop. If you don't know and you're using a condition, use a while loop. And even though you could mix them at some point that you learn in A48, do not mix them in Python. Use them separately. And we have lists. Let's take a 10-minute break, and at 6:05 we'll be back and moving on. You're going from right to left. So you're going to start from here and go left. Now, everything before it will be 0. That's something to clarify, because you're still rounding. But everything even afterwards could become 0 or could round 1 to 2 based on how large it is. So for example, if you're rounding 1/600 with 3, you're going to get 2,000. Because you're going to get rid of 6 and then add 1 to 1 because 6 is large number. But if it's 1,495 like the example, you're just going to get the same number you're seeing on the screen. That's one thing to clarify. The second thing to clarify is a typo that was found in the slides. So if you remember, we talked about for loops in over strings. Where is it? All right, here. So here there's a problem, and that is we forgot to add plus char, right? So you want to say plus char plus @. What you're doing in each iteration is you're getting one of the characters, you're getting an @ and you're updating your collecting string one at a time. And that's why you need both the char and the @. If you do not add char here, doesn't matter you're doing a for loop over char or not, you're not going to update it. And this is an idea we talked about, right? A for loop is just going to get items one at a time. You have to specify what are you doing with those items. For char in foobar, it's going to get the characters one at a time. But if you don't say what I'm doing with those characters, then nothing's going to happen. You're just going to keep going over the loop. So make sure you're using whatever is inside the for loop if you need it. Sometimes you don't need it, right? Sometimes you just say for I in range 3, I just want to do something 3 times. I don't care about I. In those scenarios, you don't need to use I. Go ahead.
So what's the difference when we say like for car and foobar and we say for I?
No difference.
So you can use like any.
Exactly. Just make sure you're using the variable. Doesn't matter what you call it, you're using it if you need to. And meaningful names are a good idea. Like for char in foobar makes much more sense than saying for bread in foobar, you know, something that doesn't make sense. Let's see where we were. So we reached lists. And do you want to join to help out? Or?
Yeah, I can do it.
Sure. So here's Alankrit. He's helped creating the slides you see. So if there's any typo, it's on me, not on him. And he's going to be talking about lists. I'm going to take control for when we see some of the questions we've seen before. And do I need to attach this to you?
And that, the whole thing. What do we have to do? Okay, let's see, what do we have? We have lists. We covered strings in this review seminar before. What is strings in very, very basic terms? It's in some sense sort of an array or sort of an list of all characters. So what do you have right now? You have a collection of items stored in a single variable. That's one list. So where's my mouse? Okay, yeah. So if you can see, you have lists which basically right now is having a 1, 2, 3, A, B, C. The important part here is in a list, you can have different data types all basically in single list. So right now I'm having an integer here which is 1, but I'm also having a character or a string here which is A. Another thing which we do with lists, which is more or less very important for your midterm, especially those MCQ sections, is how do you access an item in a list? This is important and I'll come to that. Okay, so you're having my list 0. What would this give you? 1. Okay. What would the output be if I'm doing my list 10? Like it's 1, 0 here. What would that be? Huh? Okay, we have 1 as index error. Does anybody else want to take a guess? Or like, not a guess, but yeah, okay. That would give us an index error, index out of bounds. Why? Because right now how this thing works, this square brackets works, is you take this list, which is an object in a sense, and you go to the 10th position in that list. And this is a direct function. Like if I'm having a box here, and this is part of a big box, I'm basically saying go to the 10th box in this one, which is not present. So basically out of bounds, index out of bounds. So that will give me an error, and keep that in mind for your MCQs. Adding items in a list. Append, which you do as new items. What does this do? This adds this very item to the very end of the list. So if the list is empty, this will create, this will not create a list, this will be the sole element in that very list. So if the list is empty and you append something, the new element will be the sole element in the list. Inserting, on the other hand, is similar to append, but there's a slight difference there. Why? Because you can see there are 2 parameters for this function, which is 1 and the item itself. you're doing MyList.insert the index of that very item, the index of this item which you expect it to be in the list. So if I'm having list as 1, 2, 3, and I want the new one to be at index 1, how would that happen? If I'm inserting a list, if I'm inserting an element at index 1, that would come here. So this is 0 and this is 1, so that would come at index 1. In very basic terms, the new element which is added should have the new index. Okay, now what if I'm doing insert at 10? What would that do? If I'm doing at insert 10, index error is one answer that we get. What do you guys think? Okay, when I was talking about this thing, the square brackets here, I mentioned one important part, which was this square bracket thing. When I'm accessing something like this, when I'm accessing something like this, A at this square brackets, this directly accesses that memory. So this basically goes in this big box and then tries to access the 10th box. But this here is a function which is made by Python quote-unquote developers. What they do is they error handle the inputs. So if you are giving some, not so random, but a very big input here, which in this case is for say 10, that would be error handled properly by this very function, which is the by this very function, which is the insert function. So that would not give an error then. That would not give an error. Does that make sense? It's a bit tricky, but all I want to say is, if you're using an inbuilt function, which is this insert, and you're trying to do something like this, inserting at index 10, usually that should give an error because there's no index 10. But this function error handles that error and does not throw an exception. Does that make sense? Anybody is, this is a very important topic. This probably will be of great value in your midterm. Yeah? You have a question? Yes? Pardon me, where? If you insert list at where? Yeah.
If you're listing it or the items in list was inserted
to this very list, to my list. So here what is happening is this item, which is one item, inserted item, is inserted to a specific index in my list, in this list. Does that make sense? Okay. Does that clear it out? Okay. Yes.
Wait, I don't know if I missed this, sorry, but if you say like at the index of 10,
Yeah.
it'll just be at the very end? Or,
No, it would not insert it.
because like the error of the error.
It will be an error, but it won't throw an exception. So think of it this way. I am getting an error here, but the quote unquote, the person who's supposed to run me this recognizes this error, and rather than coming to me and throwing an exception at me, telling me that he received an error, does nothing. Huh?
so nothing happens.
Nothing happens, yeah. Okay. Yes.
Does it return empty string?
The return, there's no return here first of all, it's just adding to the main list. That would have the original list. Yeah, the one which it was already. Yeah? Yes.
So if nothing happens, is it the same whether or not
Exactly.
I executed that code?
In some sense. I don't want to say it exactly the same. More or less, yeah.
Okay.
Yeah. Okay. I have a list of common errors in lists. First one is basically index error that we just covered. If I try to access something which is not in the list, it will give an error basically. Modifying the list while iterating. Why is this important? So what might happen in your midterm? You might have a question where you have to write a proper code or like a big code example for that sake, and you are iterating with while. You are iterating a list with while. What sometimes people do is they change the list when they are iterating itself. So they are iterating. So let me just do it like this. Wait. So in very basic sense, we had that example, right, for foo in list. I'm just having, because list is a defined data type, for foo in list, and then I'm iterating over this list. But what if I change the list in itself inside the loop? That usually gives an error. That might be a logical error, but that usually is an error. That you do, like if you're iterating directly over a list, you should not be changing it inside the loop. That's what this is saying. Other thing here is confusing append and extend. Append, this is important. This quote unquote might be for multiple choice. Using append when indenting to add multiple elements from another list in a nested list. Does that make sense? Yeah? Does anybody, this is simple stuff. Does anybody have any doubt in this one? No? Okay, I'm assuming a yes then. Not realizing that lists are mutable is another error. Assigning one list to another and modifying one of them, expecting the other to be unchanged. Extremely important. This was also in your worksheets. List 1 is what? List 1 is 1, 2, 3. List 2 is list 1. List 2 is list 1. If I append 4 to list 2, and then I'm trying to print list 1, what should I get? 1, 2, 3, 4, right? And yeah, it makes sense when the topic is this, but it would not make sense when you're in a rush. So be very careful with this. Like, you might have a list, and then in very basic sense, what is happening here is you're having an object list 1, and list 2 is just pointing to that very object, which is list 1 here. And if you change list 2 then, which in some sense is changing the object which it was pointing to, which also changed list 1. Yes?
If I did list 2 equals to square bracket 1, 2, 3 instead, would the aliasing still happen?
No. If you do list 2 is equals to square bracket 1, 2, 3, is that right?
Yeah.
Okay. What will happen then? Some person might think, okay, wow, the values are still the same, but, and there's a big but there, the list 2 now refers to a new object. The list 2 now refers to a new object. When I'm doing something like this, list 2 is equals to list 1, there's just one object and both of them are referring to the same thing. But when I'm doing list 2 is equals to square bracket 1, 2, 3, 4, whatnot, that is creating a new object. So I'm having two objects then, and both of them are independent of each other. Okay. Using incorrect methods for searching. Yes?
So for the not realizing list immutable bit, so
Yeah.
if I have list 1 and then like list 2 as defined, and then if I change list 1, does that affect list 2?
Yes, obviously. Because it's referring to the same object. It is referring to the...
So without rerunning list 2 equals list 1, it still changes list 2.
Okay, let me just double check have I got it right. So you're saying you're having list 1 is equals to 1, 2, 3, list 2 is equals to list 1, and then you're changing list 1.
Yeah, you do list 1 dot append.
List 1 dot append, and then you're asking will list 2 be changed?
Yeah.
Yes, because list 2 is basically list 1. It's the same object. Okay. To solve this, one, you can basically create a new object, but Python also provides a function which is list.copy. So you can use this, or you can also use this. But the main point here is they are mutable. Okay. Using incorrect methods for searching cause confusing list.index, which finds the index of the first occurrence of that value, with checking if the value is in list using in. In is a function in Python, by the way. Example, using mylist.index value without handling value error if value is not found. What do you think is happening here? Yes? No? What do you think is this all about? what does dot index do? So if I'm having list 1 dot what is this doing? What is that function doing in very basic sense? Yes?
Returns you the index of the value of the first value of your find.
Exactly. But what if A is not inside the list?
It gives an error.
Exactly. It gives an error. So how do you solve it? Okay. You can just do something like this. Before checking, to check the existence, you can do if value in my list. If value in my list, and then only do this function then, if it's present inside it. Does that make sense? If the value is present inside it, only then run that function. Because if it's not, that will give an error. Okay, let's see what's the next slide. Nested list review. Yeah.
Some question on the previous one. The one you mentioned that, no, this one, the previous one.
This
So you
one?
said, like, what's the difference when you say insert items and then index 1 and when you say index 10? So what's the main difference?
Pardon me?
It was like talking about index 1. When you say like insert 1
Insert 1, yeah.
and insert 10. So what's the difference between both?
It's more or less the same thing, but when it does not find that index in that list, it does not do anything. It would not give an error, that's the point. The thing here is, so assume if I'm having list 1 is equals to this, basically, right? If I'm having list 1 as this, and I'm trying to do list 1 at 3, which is, what is that? Let me see. That is C, for example. What will this do? What will this do? Anybody? Huh? Okay, I think there's a confusion here then. What will this do? Yes.
Add C to this one, the A, B, C.
No, wait. Why is everybody confusing this? We just went over this, guys. What will this do?
Index error.
Exactly. This will give an index error. What is list 1? List 1 is A, B, and I'm trying to change what? I'm trying to change something at 3. So what is this doing? This is going in this box and trying to find directly something which is not present. So this will give an index error. Now you want to do this, but you don't want to actually get those index errors. In some sense, what you do then is, if I'm doing list 1 dot insert at index 3 and the value is C. What will this do? This won't give an error, that's the point.
So it's error or it's nothing?
Huh? It's nothing. It won't give an error because this very function automatically handles this. Right? Yeah.
Wait, so does that add this C?
No.
So it's
Yeah.
not literally nothing.
It does nothing, yeah. Because the whole point of this is, if this is present inside the list, but if the list is not having an index 3, what are you changing in that sense?
If it was like A, B, C, D, and then like you
A, B, C, D, then that would change in some sense.
A, B, C, C.
Yeah.
Okay, so in this case, it's going to be an error, and in that case, it's not.
Error for sure, because it's directly accessing something, and that would not. Okay. How much time do we have? We are short on time. 1 second, guys. Okay. We'll go over this quickly because we have some good questions at the very end. So I want to discuss them in some sense. Okay. Everybody take a look at this for the next 10 seconds. Deep focus. Okay, data. Data is this big list of lists. Sublist. Sublist is what? Sublist is data at 2. This is at 0, this is at 1, this is at 2. So what is sublist referring to? This thing, animal 70, whatnot. Sublist at 1, sublist at 1, sorry. If this is referring to 5, what happens? Exactly, because it is mutable. Okay, what is sublist then? Animal 5. What is data then? You see this? Okay, my lines are not good here, but this changed because this was a mutable data type. We have discussed this right now. Given changed list, data, and sublist at 0 is 3. Sublist at 0 is 3. Which options will evaluate to 3? Which options will evaluate to 3? Option 1, length of data at 0. What is that at 0? This is that at 0. And how much is the length of this? 1, 2, 3. So this is 3. Length of data. How many items are there in data? 1 list, 2 list, second list. No, 1 list, 2 list, and third list. Sorry, guys. So 3 is the length. Data 2 at 0. True or false? True. Why? Because we just changed it. It is a mutable data type. Remember that. Length of sublist. What is that? Why is that false?
It would be like the length is 2.
The length is, okay, I'm saying 2, okay. The length is 2, but the answer is false. Okay, I get it. Length of data at 1, data 1 at 0. What's the length? 3. So that's true. Exactly. Okay. 10 seconds, deep focus, look at this. Huh? For the good. Yeah, at this point data is referring to this. Data copy is what? Is the whole thing. Why? It's just a colon, so it's assuming it's starting from 0 and ending at length. So exactly the whole thing. Data copy at 1, 0, and I'm making that at 42. Yeah, what do you think that is? 42, comma CS. And then what is data? It changed. Yeah? Okay. What is sublist? It's more or less the same as it comes from here. What is it? Okay, yeah, you see the answers. I get it. You're trying to be smart here. Okay. Do we want to do this? Okay, let's do this. 10 seconds, deep focus, look at this. I know this is a lot, but I'm not even kidding. This probably is the most important part of your preparation. Yeah? Focus there, not here. Okay, don't look at this part, right? Okay, let's see. Nums, empty list. For I in range 4, nums is equals to nums plus I. What is this doing? Is this addition, is this concatenation, is this string, no, string addition, not obviously, is this list addition, or what is this? Yes?
We're adding list with just I inside. So it'd be like a list containing 1, comma, list containing 2, comma.
Yes, yes. And this might be sometimes confusing because some people might think, okay, am I doing the actual addition of numbers here, or am I adding lists? Or no, I'm adding lists or concatenating lists. This plus, when done in this sense, will do what? Concatenation. But what if I'm having nums at 1? What will that do? If I'm having nums at 1 plus I, huh? Okay, this is a trick question. Let me see who can answer it.
There are different data types.
There are different data types. Okay, there's one answer from here. Different data types. Anybody else? If I'm having for I in range 4, nums is equals to nums at 1 plus I, and nums is an empty list. It's going to create a list of 1. That's one answer. Nobody? Look at this. Yeah, okay, yes.
It's going to create a list.
It's not going to create anything. Yes. Huh? It's going to give an index error, guys. See, this is what happens in the midterm. You all know, if I tell you, look at this very part, nums at 1 and nums is an empty list, you all know it's going to give an index error. But none of you did answer that when I asked you guys, right? So this is what happens in the midterm too. Be very, very careful there. It will give an index error, obviously, because nums at 1 is not present for the first iteration of the loop. Is not present for the first iteration of the loop. Does that make sense? Yes? Okay, how much time do we have? We have very less time. Okay, let's be quick. What is nums? This? Got it? It's actual string list concatenation in some sense. Nums is 7, 8, 9. Mixed is equals to this. Does this create a nested list? Yes. Okay. What is mixed? You see this? Yes. Nums is this. For I in nums range, append this whole thing. Does this create a nested list? Yes. A reference to the list at I is inserted into nums, not the reference for each element. What is nums then? What is nums? Okay. Guys, okay. I get it. Yeah, nums is basically exactly what is on the board right now. Okay, this is important. Writing out the most expensive item function. 20 seconds, deep focus, look at this. Huh? What?
It was in the last perform or prepare one.
Do you guys have you guys done this? No. Yeah? Yes? No? Yeah. Where have you done this? Okay, yeah. You want to do it again? Yeah. Do you want to just think in your head? I'll just show the solution and we'll move in 5 seconds. Okay, just think the solution. We won't discuss it. But yeah, think of it. This is a fair representation of what you might have on the midterm. Okay, now think of it. Need more time? Done. I've remembered, perform. What is happening? Yeah?
You just pull out, you can move through the list and then you can compare the elements.
We'll go with solution, but I just the solution is in the perform too. It's going to be fast, but did everybody just look at this at least? I don't want people to come here, sit, enjoy music and then leave. Right? Okay. This is what you guys have exactly on the board. The solution. Make sense? You have 1 more minute to look at that. Okay, I'm giving you 1 full minute. Yeah.
Can we not make like non-zero price as like a precondition, or like a 0 and above price?
You don't make preconditions, first of all. Those are given. Yeah.
You know how you look for item, comma, price in some price list, right?
Yeah.
We haven't learned that specific writing style. Is there another way that we can do it?
Okay. Wait, what? Okay, here's the thing. What am I doing here? For item, comma, price in price list. Where did I put the chalk? Can everybody see this part of the board? Yes? Okay. What did I have? Okay. Yeah, I'm having something like L is equals to 1, comma 2, 3, comma 4, 5, comma 6. I'm having this. Yeah. And I want to loop over them. Loop over what? Loop over the values. Loop over the values of this L. What is a value in this L? This is a value, this is a value, and then this is a value. What usually I believe you guys would have done is you're having for val in L, and then you're having I is equals to val at 0 and j is equals to val at 1. This I guess what you have done usually, yeah? This is basically the same thing in shorter form. Like item, comma price, item is the first item at 0th index in one value of this price list, and price is the second item at first index for a value in this list. Bit confusing, but if you think twice, you'll get it. Yeah, you don't have to do this. This is absolutely fine. Okay, so if you don't get it, no worries, one day before the midterm. Yes. Memory model. What's your opinion about this? Is this good, bad? I don't want to do this. No? It's very bad? It's very bad. It is bad. It is bad, but we're going to try to make it easy. We are having simple examples, and I don't expect something very difficult to come from this. Well, I am a TA and I have not seen the midterm, so you might have anything in the world, but probably not. X is equals to 100. Where is my mouse, by the way? Oh yeah, I'm here. X is equals to 100. Y is equals to 10. So, what is happening? Yes. X is equals to 100. I'm creating a new ID, which is this. And then I'm pointing it to what? I'm pointing it to a value which is 100. Next line. Where did the mouse go? Yeah. Next line is y is equals to 10. I'm creating a new object. I'm creating a new object which is ID2, which is mapped to a new thing, which is 10. Okay. L is equal to x comma y. L is equal to x comma y. So I'm creating a new object for obvious reasons, which is the list. And that list should have some values, right? Yes. What are the values of that list? Are they 10? Are they 100? Or what is it? What are the values of the list?
10, 100.
No.
100, 10.
No. What are the values of a list? Or to be like very clear with my question, I think it's clear enough. What are the values of a list? It's not 100 or 10. It's x comma y. Yeah, this is important. Why is this important? Because if this was 100 comma 10, and I want everybody's attention here, if this was 100 comma 10, I would have 100 here and 10 here. But what is this? X comma y. So what am I having? ID1 and ID2. The positions of this x, which is this. And this automatically refers to, so the arrow goes from here to here and then back to here. Right? So it is in some sense, as your friend said, 10 comma 100 comma 10, but not really. Yes.
So if I change the value of x, that the
what do you think it would do? If you change the value of x, and think logically everyone, if you change the value of x, what will that do? That will change the value of ID1. That will change the value of ID1. Will that change the list? Yeah. Exactly, because list is ID1, comma ID2, right? Okay. Okay, the answers are on the board, but don't look at them, even though they're highlighted very clearly. Okay, what happened here? I zoomed in, I guess. Yeah. Okay, yeah, try it. 10 seconds, deep focus, look at the board and read it.
Can you get like the same question but for two?
Pardon me?
Can you get the same thing but for an immutable object? Like in the case of x.
This is a past midterm question, by the way. So this is very much in syllabus. Okay, basic question. Any doubts? Any doubts? So I'm assuming everybody got everything? Did everybody get everything? Yeah? So I'm moving on then. Yeah? Don't be shy. Like if you don't get it, just tell me, or like we'll go over it.
I didn't get it.
You didn't get it, okay. Why did you not get it?
So how like Z is ID1, ID2?
Z is ID1, ID2, okay. Yeah. No. What is ID1? What is ID1 here? It's this. Huh? Value 10, exactly. What is ID2?
100.
No, it's this. Like it's value 100, but it's this box. Box is important, guys. What is X referring to? What is X referring to? ID2. What is Y referring to? ID2. Okay. Oh, shit. X and Y refers to the same memory object. Does that make sense? Yes. X comma Y0 refer to the same memory object. What is Y0? Oh, sorry. Yeah. Z0. Yeah. Z0. That's ID1. The question is saying X comma ID1 are the same thing. No. X is what? X is ID2. So this is false. Right? Yes. X comma ID1 refer to the same memory object. Yeah? Why? Because both of them are ID2. Y, yeah, same, ID2. Make sense? Y and Z at 1. This is Z at 0 and this is Z at 1. So Y is what? Y is ID2 and Z at index 1 is also ID2. Make sense? You get it?
Yeah, I got it.
Does everybody get it? Sounds good. I'll take that as a yes. We have 10 minutes and we have long way to go. Let's keep it that way. Okay. Fair examples of what you might have in the midterm. Some of them are created by me. Some of them are created by your profs, which were in past midterms in some sense. Right? Okay. 20 seconds. We won't have that much time. Look at this. Deep focus and try solving it.
What are you guys going to be posting the slides?
I need to double check, but I'm pretty sure we can. You have the recording.
Oh, what's going to be like on the AMACSS?
Probably before your midterm. 100% before your midterm, but I can't guarantee a date right now.
You said like you guys going to share the slides. You just need the slides.
I need to double check with the prof. Did Adib confirm it?
Yeah, they said like that.
I'll double check with the prof, but I'm pretty sure there should be no problem.
Helpful if you guys can post this.
Yeah. We'll probably post them, but
But is it going to be like
Yeah,
on
yeah.
purpose? It's going to be posted?
we'll see. We might post on Piazza, Quarkus, or AMACSS Discord if you want to join that. Okay. where were we? We were on this question 1. Define a function, swap characters. Okay, focus. Define a function, swap characters, that takes a string and 2 indices and returns a result of swapping characters in a given string at the given index. So swap characters is the function name. We are getting 2 indices and we're getting a string. Okay. For example, swap chars or swap characters. CSCA08 1, 4 should return the result after swapping indices at 1, 4, which is which will result in this. Does everybody get it? This is a fairly easy one. 20 seconds, think of the answer in your mind or write it in a rough notebook if you have any. There's no point in coming to this review seminar if you listen to this as music or for some as noise. But the only benefit is you'll get the benefit if you do these questions. Yes?
When it says the indices are non-negative, what does that mean when we do that?
Okay, so let's come back to this. What if I'm having list 1 at, okay, no, Python is bad at this. Okay, let me just complete my sentence. If I'm having list 1 at -1, what will this give me? Huh? Huh? No, nothing to do with length. What will this give you? List 1 at index -1. Huh? The last element. This will give you the last element. The last element, not element. Yeah, the last element. Does everybody is that clear for everybody? The question here is, where's my mouse? Yeah. It says somewhere here that the indices are not negative. That basically means, in very simple sense, that there are no negative indexes in the given inputs. That's a, precondition in some sense. You don't have to check that. That's what it's saying.
So is it like you cannot use a negative index, or there is no given?
The input won't be negative. That's a precondition in some sense. Yeah. You may assume that the given indexes are non-negative. Okay. Short on time. Read this and we'll move. Also, a lot of people get this part right. Oh, sorry guys. A lot of the people get the actual function right and mess up in the doc string. So don't be one of them. This is also equally important. This is a good example which you might just copy in your brain and then print in your exam with some modifications obviously. Oh wait, sorry. Wait. Yes, it's here. No, okay, yeah. This is bad right now. Does everybody get it? So this is the statement which describes the function. These are the preconditions which my friend over here asked. Important to mention. And this is what? What is this? In some sense examples, yeah. Minimum 2 examples for each function. Okay.
So the non-negative indices, that's the precondition. Yeah?
That's the precondition. Exactly. Does everybody get this? This is fairly simple. So you are swapping it. Does anybody need any explanation on this? I'll move in like 10 seconds. Yes. Wait. Yes.
For the solution of this question, do we have to add the bracket, the highlight?
You don't have to highlight it. Wait, if I'm not getting a question. Wait, are you asking if you need this bracket? Yes. Why? Because it's for the clarity of the TA. Simple sense. Guys, you're writing on paper, you already are very, how do I say it? It's bad. Writing code on paper is bad. Why do you want to make it worse? Right? So in simple sense, yes. But if a question is, if I'm writing it on IDE, a Python IDE, do I need this? The solution, the answer for that is usually yes, because that's a standard coding practice. But if your thing is like simple, return true, Like, come on, this is fairly simple. You can skip brackets here. But if it's like this long statement, yeah, obviously, bro, come on, like write this. Simple, yeah.
Indentation is important. You have to do the indentation part.
Do you remember in your assignment there was, so if this was your wing IDE, there was a light blue line somewhere running here. You remember that?
Yeah.
Does everybody remember that? Hopefully. Yes. That basically means that you don't write your code in one line. To stop that and to make it, to beautify it, you do something like this. Yes?
So in our exam, do we have to like pay attention to the number of characters in one line?
No, don't be counting. I need 54 characters in this string. No, not at all. But in simple sense, this is obvious. Like, this is a very long line. Yes.
Just for this example, now you said return and it's very long.
Yeah.
Right?
Yeah.
So when you do the second line, do you have to indent?
Indentation for CSCA08 is very important. Yes.
Okay, so it's not right after the return.
Yes. Yes.
So for the midterm, we have to write it on two separate lines, not one big line, because of like the blue line rule.
Okay, let me give you a student answer for this. In very simple sense, this is rare. This long line is rare. But if you see a long line which is not even fitting in your page, obviously switch it and write it down. That's the student answer. Yes?
Rob said it in the lectures that if we have a very long line,
Yeah.
it's obviously understandable if it's like going out of the page, you can easily write it underneath the last words.
Yeah. Okay. Does everybody, I didn't spend time on this. Everybody got this? Yeah.
For a function, if it extends and you want to move on to the next line, do we need backslash n on the example? We don't, right?
Wait, okay. Let me listen to this carefully. What is the question?
The question is, I have a long function, maybe a sum of 10 things. So
Okay.
do I use backslash n to move the things to the next line?
No, don't worry about that. Yeah. Don't worry about that, yeah. Okay. Whew. We'll share the slides, probably. See, I can't say on his, but I will try to share slides. Do you guys have any stuff right now, or are you guys leaving right now?
Are you done now?
Huh? It's not done. It is not done. If you guys want to leave, you can leave. I'll be here for like next 5 minutes. I'll at least go over the questions.
You're going to the end?
Huh?
Or you're going to the end of the question?
I'll go over all the questions, like at least go over them once. Huh? Yeah. Okay, this is not good. Okay, let's take a break for 5 minutes. People who want to leave can leave, and people who want to stay can stay. There's a break for 5 minutes.
Just in between, can I do a chart? So, Alan, so for example.
We can start. Okay, we'll go over this very fast because we are already due or like over time. Check. Question 2, Boolean if statements. 10 seconds, read it. Okay, done? Yes? Do you have a solution? Do you have an idea in your head? Did you at least read it? Okay, let's move on. This is all. Wait. I can't undo it? Okay, never mind. So you had this, right? You can write it in some sense like this. Yeah? Does that make sense? It's very simple if you think like twice. It won't come directly. Yeah.
So all of the code gets simplified to that last line?
Yes.
So it's not like on top of it, it's just.
No. It's the thing. Like it's just that line
So
there.
you don't need the if and the else.
What do you think of the statement that makes? So just checking if the amount is else it becomes. So like you put in.
Okay, see what is this doing? This is returning not. Important. Flag that down. Not. Is taxable product. Is product taxable? Is product taxable? If the product is taxable is true, what does happen? what happens then? If, okay, this is very important and will probably be on your midterm. Not 100% though. I can't be sure, guys. If this is true, what happens?
It just doesn't consider the last.
It does not consider the. I said something 3 times, and what was that?
What is the answer? You said what
No,
is
no,
the
no.
answer?
I said there is something as NOT mentioned here. So if this is true,
It becomes false.
this whole thing becomes false. Do you get it?
Sorry?
So this thing will be considered then. No?
Doesn't.
You guys did something as short circuiting,
Yeah.
which was very important. It is. And if in an OR statement, or if in a statement which is joined by OR, the first thing is true, what happens? You exit. Because if it's A or B, if A is true, okay, I don't want to take for B. Yeah. If is taxable returns true, what happens?
Then it's not.
It's not true. I mean, it's false. Does this run?
The second condition. If it's false, you go to the second condition. If the not is false, you go to the second condition.
I think you got it, yeah. Hopefully. So yes, if this whole part here is false, oh, till here, sorry, till here, if that's false, then this will run. If this is true, then this won't run. Now check this. What? Yeah. If is taxable is false, then you directly return true. If is taxable is false, then you return true. What happens here? If this is false, if is taxable is false, what is this? That is true. I need return true. So exactly like this, right? And then if it's not true, then you basically go and do this, which is this. I have a habit of drawing lines over lines. Okay. Did everybody get that? Hopefully. Move on to question 3. Yes, quick. Yeah, focus. 10, 9, 8, 7. Yeah. Provide a full doc string is the question. Okay. This is the solution. Oh, sorry. I mean this. Sorry guys for that. Oh, this is better. Yes. Does everybody get that? Like all the basic or the most important point here is you memorize the format. The first thing describes the function. Second thing is the precondition and everything. The third thing here is talking about the examples. Okay, and minimum 2 examples. And then you go on to edge cases. Does everybody here know what are edge cases? Yes? No? Okay. We'll cover that after the thing. Yeah, not right now. We need to cover like 4 more questions. Oh, where am I? Yes.
Do you earn extra credit for edge cases?
Pardon me?
Like if I just have 2 examples.
If they say, if the question is worth 2 points and they're asking you to write a whole doc string, no edge cases required, like obviously. Okay, not obviously. I can't be 100% on anything right now, but yeah, like it's less certain that they'll mark you for the edge cases. But if the question is like 10 marks and the first line is just like 20 characters and the function is obviously having a lot of edge cases, yeah, then do edge cases. Edge cases in simple sense is, so if you want to test, if the function is importing a string, what are some edge cases? What are some cases? Let's go with that. Empty string, some string,
Like non-alphanumeric string, you put like an at inside.
okay, we can consider that. A string with 1 character. So rather than saying a string, say empty string, a string with 1 character, a string with 2 or more characters. So those are 3 basic cases which usually cover all of this. What did I do? I took the function which imports a string. I thought of all possible edge cases on that string, on the input. And then I basically tried to find edge cases. or like find all possible cases which might break or make your program, make or break. It might not be very clear, but in simple sense, consider the function and think of places where it can break and write those as your edge cases. Yeah, exactly. Yes. 20 seconds, read this. We are well over time, so 10 seconds, read this. Okay. I can't go over this, so this is the solution. Did everybody read that? There's no point in taking pictures if you don't even view them after. But there's a point if you read them right now and keep them in your, not RAM, ROM. Yeah? Okay. Done? Okay. Now I'm going to like do very fast. Did you guys do this? General palindrome checker? No. You didn't do this? No. Okay, this is like important. Suppose we're trying to find out whether a given string is a palindrome or not. What is a palindrome? It's the same forwards backwards. Give me a definition of palindrome in computer science. How will you check it? You can't do, hey computer, if it's same backwards forwards. Yes.
You can get it, like you can use indices to like print the string forward and then backwards, and then like, you can check it repeatedly.
Valid. Any other idea? Yes.
Using the sorting, like making the string or the thing that we have like half, and then check if this one is equal to this one, like some abstract.
A bit dicey on that. Yes. No? Yes. That's a valid option and an easy one.
I think we can.
No. Okay. Next.
Just to check, we can like break it into half.
We can break. Okay. We have a string. Okay. What I want you guys to know is think how I'm thinking right now, or like learn how I'm thinking right now. Sorry. Like I'm following a particular state of process. I'm following a particular process. Like I'm thinking a very particular direction. Yes, go.
So I said we take the string.
We take the string.
Yeah, we break it into half.
We break into half. So we're having a string, break into half.
Yeah.
Half is from the middle. Yes.
Yeah, and then we can reverse that half and compare it to the other half.
You can reverse the first half and then compare it to the second half. Is that what you said?
Yes, I want.
Sorry, I didn't get it firstly. That should be fine. That again is an edge case then. Yeah. Do you have a solution for that then? No. Huh? If it's okay, think over this.
If it's odd, automatically the central element
Is in both.
is in both.
Yeah, so it doesn't matter actually. It really depends as to how you implement the code, but basic sense in if it's of length, which is odd, the center one, which is, so if it's like A, B, C, this is in both. So if you can do something like this, reversed is equal to this. Yeah? This is not palindrome first of all. Huh? Not really, you can do directly too, but don't go on to that right now. Right now your thought process should be very simple one, which is, what is a palindrome? It starts, it has the same, so if this is the palindrome, A, B, B, A. Is this a valid palindrome? Yes, it is. So the whole idea is, index, the value at index 0 is equal to the value at index, what? Minus 1. Yeah, minus n. So this is n, this is minus n. Right? And if you can run the whole function with this, comparing all these n and minus n, and none of them return false, that means it is a valid palindrome. Let's see what we have. That's not an efficient way, but that's a way what you can think of easily.
But so what would be the most efficient way to solve this question?
If you want the most efficient way is this with an early break. Yeah, it's basically short circuiting on a loop. So don't go on that.
Wait. You said n and negative
N.
and then you define.
No. Not negative n, my friend. It should be negative n.
1 minus n.
Negative of n plus 1. Yeah. It should be negative of n plus 1. And then that will be negative of n minus 1. So what you are doing is you are comparing the list. You are comparing index 0 with minus 1. 0 with minus 1. 1 with minus 2. Yeah? Okay. Let's see what we have. We are well over time and I need to go to. Yeah, 3 ways. Yes, we have 3 ways. You see this? This is not efficient though. This is shorter. Yeah? Okay, moving on. General palindrome but better. General palindrome but better. Yeah, just take a picture and then view it later. I can't go over this right now. This is basically what we said right now. It will make sense if you read it once.
What was the problem with the really short one where you just replace the order?
The problem here is, what if I'm given a string? What if I'm having something? Wow. If I'm having something like L is equal to A, B, C, D, E, D, C, B, A, and M. Yes, is this palindrome? It is not a palindrome because there's a M here, right? What will this last one do? The third option here. This will first have this and then convert the whole list backwards. That's a lot of operations, my friend. Yes, what you could have easily done is just compare this and this. If this is false, then you return false. You don't have to convert the whole thing and then compare. That's a lot of operations. That was.
Would that be okay in the exam? Like if we write that on the
If there is a thing in the exam which mentions write efficient code, you might lose some points.
So online, will this be in the midterm, the palindrome?
I don't know. Huh?
We didn't cover it.
That's why I'm covering it.
Okay.
Yeah. I don't know I have not seen the midterm, my friend. Yeah, everybody on the stream, everybody on here, like everybody. I have not seen the midterm. Okay. I think this is the last one. Yes. No. There's one remaining. One remains. Patience. I'm also waiting, guys. Yes. Yeah, check it, read it. The silence in the room is amazing. Yeah, focus. This is a difficult one. Ready? Does anybody want to tell what is happening in here and happening in this very function? Except you. Somebody else. Like I want to give everybody a chance. Okay, let's see. Yeah, except you three. No, like no hate, but like I want everybody to engage. Yeah? Yes? There's no harm if you get it wrong. No? No? Just explain what is happening. What do you get from this question? Don't read the question, obviously, but Do you guys even understand what is happening? No? Okay, yes.
I think it's removing the the punctuation, white space, and all of the stuff from the text, and then it's checking the is palindrome or not. So we should, because it's I think this is a string, so we can like do the methods first to like, for example, do the white spaces and yeah, remove those stuff, and then when we have the string itself, check for the is palindrome.
Did everybody listen that? That was absolutely right, like 100% right. That is exactly what we're supposed to somehow do. Like there are different ways, but this is a very valid way. What is happening? This question is asking you to check if the given string is a valid palindrome. We did that. How is this different? This is different because this doesn't matter. Okay, read this. Return true if and only if text is a palindrome. For a more general definition of a palindrome, case, white space, and punctuations are ignored. Case, white space, punctuations are ignored. That's the important part. What do you think about this? Why is this true? Oh, I made a smiley face. Why is this true? Huh? This is empty. Yeah, if it's empty, yeah, it's same, right? If you don't have anything, it's same. Assume that. Okay, next is real palindrome. This is real one. A man, or whatnot. Yeah, this string. Yeah. Is this a palindrome? Yeah, do you guys get it? You don't have to consider the punctuations. If you were to consider the punctuations, this would be different because see, this, can I erase this? Yeah, the letter or the character at the last index is not same as the character at the first index. So this should be false, but in our definition of a new, or the real palindrome, this is fine because we don't consider these characters. Okay, moment of truth. Yes. I won't really explain this, but if you guys want to know, you can know this. What is happening? You have described a list of all the special characters. You have described the list of all the special characters, which is empty, dot, comma, semicolon, whatnot, like the whole thing, right? For char or char, if somebody likes to call it that, in specials, text is equals to text dot replace char with an empty string. Dot replace, does that ring any bells? Does that sound familiar? Where from? String functions. Now a question was, do you all need to memorize those string functions? The answer for that is no, because you will have a sheet in the midterm which will give you all the string functions. A good point is when, okay, real story, I was writing my midterm and I was messed up for one question and I just didn't know what to do. What came to my rescue was reading that sheet 10 times. 10 times is a hyperbola here, but reading it again and again, I found a function which was exactly what I needed. So sometimes that is useful. Like dot replace is a really important function here. If you were to do what exactly you were saying, then that would be like a 50-line code. 50 is too much, but it's going to be a long code. Dot replace basically solves the whole thing here. This is basically removing all those special characters from the string. Removing all the special characters from the string. There might be a question in the midterm, just remove all the special characters in the string. How do you do that? This is the way. Converting it to lowercase because case doesn't matter, and then returning our old function, because then we can just check is palindrome. Make sense, everybody? Yeah. Okay, that brings us to, thank you for watching or thank you for attending.